Welcome! In this session, we're going to be working with polynomials. So let's take a look at some examples. Something like 2x squared or 4a to the fourth. Things like this would be monomials. A binomial would have two terms. So two monomials put together either with a plus or minus sign. And here's an example of a binomial. 4y cubed minus 5x. So it's two monomials hooked either with a plus or a minus sign. So we could have 8 z to the fifth plus 7x to the third. That would be another example of a binomial. And a trinomial is a polynomial of three terms. So again, monomials hooked up with plus or minus, and there's three of them, like 7xy minus 2z squared plus 5mn would be an example of a trinomial. Now, generally speaking, when we do and write polynomials, we like to put them in descending order. So what do I mean by that? Well, if I had something like, let's say, x to the fourth power plus 2, that's 4, 2x to the third minus 3x squared plus 5x minus 3. Putting it in descending order looks something like that. Then talking about what is the degree of the polynomial. The degree of the polynomial in one variable is the largest exponent. So the degree of this, it would have a degree of 4. This trinomial would have a degree of 5. It's written in descending order, 5, 3, and then no x's, and it has a degree. The highest exponent is 5. So now we're going to talk about adding and subtracting polynomials. So if I had 7y squared minus 6y minus 3, and I want to add to that minus 2y squared plus y plus 5, I'm going to add these. Now there's different ways that people can add. Some like to add vertically, some like to stack it like we do numbers. So if I had 325 plus 20, you'd stack it and you'd put so the 5 goes with the 0, 2 plus 2, 4, and 3. And to have 345, because we know that's the ones place, the tens, and the hundreds place. Well, we can do the same thing with polynomials, where we put like terms together. So I have my y squared, here's my y, and just y to the 0, or no y's in there. I'm going to add to it this negative 2y squared plus y plus 5. So you add your like terms. So that'd be 2 in here. And then negative 6y plus y is negative 5y. And 7y squared minus 2y is that 5y squared. So that would be the result. The other way, if you like to go vertically, if you had this, my next step would be to take it out of the parentheses. Since that's a plus, none of the signs change in there, so I'd say negative 2y squared plus y plus 5. And then I'd put my like terms together and add them. So 7y squared minus 2y, 5y squared. 6y with the plus y would give me the minus 5y. And then these are like terms. So I'd say 5 minus 3. That gives me a plus 2. So it's just another method. It's how you like to see things and put them together. So let's look at two more examples. So I'm going to look at this example. So I say, okay, x squared plus 7x, and then I'm going to subtract off 3x squared minus 4x. because that's the negative sign would say that. So I take these two. X squared plus a negative 3x squared would give me negative 2x squared. 7x minus 4x plus 3x. I look at this second one, and x squared plus x plus 5, and then I'd say 3x squared minus 5x minus 2, and I'd add these. So I have my 4x squared, negative 4x, plus 3. So 3 plus 1x is the 4x, negative 5 plus 1x gives me the negative 4x, and 5 minus 2, or 5 plus a negative 2, gives me the 3. I could have something like this, where I have 5x to the third minus 6x squared plus 3x, and I want to add to that x squared minus r plus 2. So if I stack this, I'd have to note in here, I have 3, 2, 1, and then no x's. And then this one, it starts with the x squared. Oh, and that should be an x. Minus x plus 2. So I could think that there's a understood plus 0 there, and as kind of a placeholder. So I have 5x to the third, because there's a placeholder of 0 there also. Negative 6x squared plus x, negative 5x squared, 3x minus x plus 2x, and then 0 plus 2 as plus 2. So many different ways to do that. So now let's take a look at subtraction. So if I had an equation like this, I have to be careful, because this negative sign in front of this parenthesis tells me that I need to change all the signs in here, because I'm saying take the negative of everything inside of here. Or you could think of it as an understood 1 and distributing negative 1 throughout the whole parentheses, however you like to think about it. So if I did this, I would do the stacking method, where I'd rewrite this as 3, 2, 1, and x to the 0. And then once I take the negative of everything inside here, so negative 1 times negative 2 would give me a positive 2x cubed, negative 6x squared, negative 1 times that would be a plus 3x, and then plus 7. Once I've taken the negative, I can now add the two together, because I've already taken the negative of it, and now it's time to add it. So I could say in here that this is 3x squared minus 12x squared plus 5x plus 12. That's looking at it if you stack it. And if I did it vertically, looking at it, keeping the equation like that, taking away the parentheses, and then I'd say negative 1 times 2, negative 2x cubed, that would give me positive 2x cubed. Negative 1 times positive 6x is negative 6x squared. Negative 1 times negative 3x gives me that positive 3x. And negative 1 times negative 7 is a plus 7. And you can see they match. And so I just would add the like terms to one, just like I did here. So that would give me the 3x squared. Then these terms are alike. Negative 6x squared minus 6x squared is minus 12x squared. Then I have 2x to 3x gives me that plus 5x. And then 5 goes with 7. 5 plus 7 gives me that 12. And again, you get identical answers because it's just a different technique for getting, subtracting two polynomials. So let's look at another example. So I have this. If I wanted to do it the vertical method, I could say 5a cubed minus 2a plus 1 minus a cubed. Negative 1 times that would give me a plus 2a. So see, if I put that understood negative 1 and distributed it through, changes all of the signs inside of it. And then add your like terms. So 4a cubed minus a to the third would give me 3a cubed. 2a with a positive 2a, that would give 0. They cancel each other out. And then 1 plus a negative 3, or 1 minus 3 would give me minus 2, and you'd have your answer there. And again, you could stack it, making sure you distribute the negative 1 in there and say negative a cubed plus 2a minus 3, and then add them. That's your 0, so I'd have 3a cubed minus 2. Let's look at multiplying. If we look at multiplying, let's say that I had 3x squared y, and I'm multiplying it by 12x y to the 5th. When I do that, you multiply number times number, so 3 times 12 gives me 36. And I have two x's, x squared, being multiplied by another x, so that gives me altogether 3 x's. And y times y to the 5th would be y to the 6th power. If I had something like 2a to the 3rd y to the 6th times negative 3a to the 4th y to the 7th, it would be the same technique. I'd go number to number, so 2 times minus 3 would give me a negative 6. A to the 3rd times a to the 4th, that's a to the 7th, and then y to the 6th, y to the 7th would give me y to the 13th power. I could have something like this, 3x times 2x squared y to the 3rd power. The first thing I have to do is I have to bring the 3rd power into here, and then I multiply. So I'd say, okay, this is 3x times 2 to the 3rd power, x to the 6th power, y to the 3rd power. So that would give me 3x times 8, x to the 6th, y to the 3rd, and now I'm back to saying 3 times 8, that's 24, x times x to the 6th, well, that would be 7x's being multiplied together, and y to the 3rd. And we could also have it to where we have a monomial with a polynomial. So something like this, where we have, let's say, 2x times x squared minus 3x plus 5. When you have this, you distribute just like always. You distributed 2x to each of the different terms inside the parentheses. So 2x times x squared, I would have 2 times 3x's being multiplied together. Then 2x times 3x, or negative 3x, that would be minus 6x squared. And 2x times 5 would give me 10x. We now could have something where we'd have something like x minus 3 times x cubed minus x squared plus 3x minus 1. With this, we're going to distribute each of these in front one by one. So I'd say x times x cubed to give me x to the 4th. X times negative x squared would give me negative x to the 3rd. Then I'd say x times 3x would give me positive 3x squared, and x times minus 1 would give me minus x. Then I'd take my negative 3. Negative 3 times x cubed would give me a minus 3x squared. The way I like to do is I like to hook them up together and sort of stack them as I do it. Negative 3 times negative x squared would give me a positive 3x squared, and negative 3 times negative 1 would give me negative 3 times positive 3x would give me a minus 9x, and negative 3 times a negative 1 would be a plus 3 here. And now I add my like terms. So I'd have x to the 4th, because there's nothing there, there's a 0, negative x cubed minus 3x cubed, or adding them together, I'd have a minus 4x cubed. I have 3x squared and another 3x squared. That would give me 6x squared. Negative x plus a negative 9x would give me negative 10x plus 3. And so now I have distributed that through multiplying polynomials. Now another method for doing this would be to take the larger polynomial, put it on top, and put the smaller one here and kind of do it like we do multiplication. So I take this negative 3 and multiply it through. So negative 3 times negative 1 gives me a positive 3. Negative 3 times a positive 3x gives me a negative 9x. Negative 3 times a negative x squared gives me a positive 3x squared. And negative 3 times x cubed would give me a negative 3x cubed. Now I take the x and I say x times negative 1 gives me a minus x. X times 3x gives me a positive 3x squared. X times negative x squared gives me a negative x cubed. And x times x cubed gives me a positive x to the fourth. And guess what? We're going to get the same answer we had before, just done in a different method. So you choose which way you like best. Now we're going to take a look at something that's special. It's binomials. That's where we take something like this, where we have x plus 3 times x minus 2. And we multiply these together. We call it FOIL, to FOIL it, because we take the first to the first. That's F for FOIL, the F in FOIL, to the first to the first to give us x squared. The x to the negative 2, they're the two outer numbers. So here's the F and here's the O for outer. So x times that would give negative 2x. Then the inners to give us the plus 3x. And then the last two numbers, 3 to minus 2, would give me minus 6. First, outer, inner, last, to give us that F-O-I-L, FOIL. So when we do this, adding our like terms, no, it would just be x, because negative 2x plus 3x gives me x minus 6. And now we've multiplied our two binomials together. And if you note, this term right here, this negative 6, the two terms in the middle here are the factors that when multiplied together give me 6, and when add together give me the middle term. We'll need that in just a little bit when we're factoring. Let's look at another one. Let's do 5x minus 2 times 2x plus 3. So I go 5 times 2 to give me the 10x. 5x times the positive 3 to give me, and that was 10x squared when I did that because there was 2 x's. 5x times 3 gives me 15x. Negative 2 times 2x gives me negative 4x. And negative 2 times 3 gives me negative 6. And then I add the like terms, so I have 10x squared plus 11x minus 6. Now we're going to look at some special binomials. This way of multiplying binomials, this special binomial, will always get the difference of two squares. So what would that look like? If I have a plus b, where a is any number, b is any number, and then a minus b, let's FOIL this out and see what will always happen. I'd have the square of the first, then negative ab. Then look at this. BA is the same thing as AB plus AB, and then negative B squared. This will give us the difference of two squares. So when we multiply a number added to another number to that same number subtracted by that second number, we will always get the square of the first minus the square of the second. So if I had x minus 5, x plus 5, I know my answer will be the square of the first minus the square of the second. And you could always test it out. X squared plus 5x minus 5x minus 25. And as you can see, those will always cancel each other out, leaving you x squared minus 25, the square of the first minus the square of the second. So if I had 2x minus 7, 2x plus 7, I would get the square of the first. The square of 2x is 4x squared, and the square of 7 is 49. So my answer would be the square of the first minus the square of the second. Then we have something when we look at a binomial like this, but this time instead of it being a different sign in there, we have exactly the same. A plus b being squared, or a plus b times a plus b. When you do this, you'll always get a squared plus ab plus ba, which is the same thing as ab, plus b squared. So you would always get a squared plus twice their product and the square of the last. So if I had x plus 5 squared, I know that the answer would be the square of the first, their product 5x, twice their product, so 10x, and the square of the last. If I had x minus 5 squared, it'd be the square of the first, twice their product. X times a minus 5 is minus 5x, and twice that would be negative 10x. So negative 10x and the square of the last plus 25. And let's FOIL it out and make sure that that's what we would get. X squared minus 5x minus 5x. Negative 5 times negative 5 is that plus 25. So x squared minus 10x plus 25. Twice their product, because we see it twice when it's being squared. So let's say we had this problem right here. Just like any other fraction, we'd have to, because it has different terms, that means 3x goes into this term, 3x goes into that term, 3x goes into this term. So this breaks up into being 3x squared over 3x minus 3x squared divided by 3x plus 9x divided by 3x. So 3 goes into 6, 2. X goes into x cubed, leaving me 2 x's. 3 goes into 3, leaving me 1. X goes into x squared, leaving me just an x. 3 goes into 9. 3 times x goes into x, leaving me 1. So my answer is 2x squared minus x plus 3. Now another way to look at this is to use long division and say 3x goes into 6x cubed minus 3x squared plus 9x. And you'd literally say, what must I multiply 3x by to get 6x squared? I'd have to multiply, look at number to number, would be a 2, and x into x to the third leaves me x squared. So when I multiply these two together, 2 times 3 is 6, x cubed, I subtract those, and I'd get 0. Bring down the 3x squared. 3x into negative 3x squared. Do you note that's exactly what we did here? So that would give me a minus x, because minus x times 3x gives me negative 3x squared. I subtract, which means that sign is going to change, and that sign will change. So these guys would cancel each other out. So look what I did there. In regular division, we subtract these two. So when I subtract this, that's going to change it. You have the negative with the negative 2 adding it. So these guys would be 0, and I bring down the 9x, and I say 3x into 9x is 3, because 3 times that would give me 9x. Subtract those two and get a 0. We get the same thing. So it's kind of going back to your division. So in other words, if I had 5 into 275, I'd say 5 went into 27, 5. 5 times 5 is 25. We subtracted those from each other to get a 2. We bring down the positive 5 to get 25, and we'd say 5 into 5 gives me 25 with a remainder of 0. And that's, what we did with integers, we do with polynomials too. So that's how you would use long division. So let's look at something like this. If I had x squared minus 1 divided by x plus 1, how would I work this one out? Now I couldn't do it like that per se, so I'd have to go in here and say x plus 1 divided into x squared. I need to put a placeholder for the x term when I use long division. So I'm going to say I take the leading numbers and I say x into x squared, that would be x. Then I'd say x times that is x squared, x times that is plus 1x. When I subtract these two, this becomes a negative, this becomes a negative. Now I can add, and I'd have negative 1x minus 1. Then I'd say x goes into negative 1x, negative 1 times. So negative 1 times that gives me this negative 1x minus 1. And when I subtract it, all of these become positive and they cancel each other out. So I would say this equals x minus 1. And when we learn factoring, we'll figure out how all this works. So let's look at this one. No easy way to do it, so we're going to work it out. So I look at this to this. I say x, what do I need to multiply x by to get x squared? Just by x. Then I take x and multiply it by x plus 1 and to get the x squared plus x. Subtract. So if I subtract, this becomes a negative, that becomes a negative, and then I can add them together, right? When I change their sign, I can add them. X squared minus x squared gives me 0. 2x minus x gives me x. Bring down the plus 1, and I say, oh, x goes into x one time, and 1 times x is x. 1 times 1 is 1. If I subtract, that means this becomes negative and that becomes negative, and I can add them together to get 0. So this is x plus 1. Because remember, now again, think about what we did when we do division. We'd say 2 goes into 3 one time. 1 times 2 gives me 2. Just like we said, x times this gives me x squared plus 1. Then we subtract. So we say 3 plus a minus 2. Right? We could make that a plus, and this becomes a negative 2. So 3 minus 2 gives me 1. Bring down the 2. 2 goes into 12 6 times. 6 times 2 is 12. Subtract it. So we're subtracting these. So I can make that a plus, change that sign, and say just add 12 plus a negative 12 to give me 0. But we'd have to bring down the 6, and we say 2 goes into 6 3 times. 3 times 2 is 6. Subtract these two and get the 0. We're doing the same kind of method here. Let's look at another one. If I had x squared plus 10x plus 25, and I'm going to divide that by x plus 5. So I put that outside the house, x squared, 10x plus 25. I don't need a placeholder because I see 2, 1, and no x's. So I go x into x squared. I just have to multiply it by x because x times x gives me x squared. X times 5 gives me a positive 5x. But I need to subtract this. So I change all the signs on these, and then I can add them once I do the sign change. So 10x minus 5x is 5x. Bring down that plus 25. X, to give me 5x, I'd have to multiply it by positive 5. So 5 times x is 5x. 5 times 5 is positive 25. And I have to subtract this, so I change all the signs, so then I can add them together. So again, what I'm doing here, so when I had this, I I have to subtract those two. And what I'm doing is I said, okay, what I'm going to do in here is change all the signs. So this becomes 5x minus 25. And now I can just add things together. So 5x minus 5x gives me 0. 25 minus 25 gives me 0. So this would equal x plus 5. Well, this is working with polynomials. Thanks so much for watching.